was gonna say we're like at half the quarter. It's not the beginning.
4.3. Solve x squared plus bx plus c equals 0 by factoring. What is this freaking out for? Oh. All right, so we're going to be factoring without a number in front of x, and then also doing some special types in this section. So number 4, we're factoring. If it can't be factored, then we need to say not factorable or can't be factored or something like that. So number 4, x squared minus 7x plus 10. So I need factors of 10 that when added together give me negative 7.
5 and 2. Well, negative 5, negative 2.
Yep, negative 5 and negative 2. Because there's nothing in front of here, I can just set up my two things and do x minus 5 and x minus 2. When we get into the section tomorrow, we'll have to do it, obviously, by grouping. Yeah. This is way easier than, well, what's coming. All right, 6. R squared plus 15r plus 56. So I need factors of 56 that add up to give me 15. So what times what?
7.
Yep. And everything's positive, so I'll have r plus 7 and r plus 8.
Yippee. What?
8. Q squared minus 11q plus 28. So I need factors of 28 that when added together give me negative 11.
Negative 7, negative 4.
Yep, negative 7, negative 4. So I've got q minus 7 and q minus 4.
Yay.
And there's never a reason to get these wrong because you can FOIL them back to check them. I know these ones are right, so I'm not checking them, but I would strongly encourage you check them so that you don't get them wrong. All right, 10, x squared minus 4x minus 12. Factors of negative 12 that give me negative 4 when I add them together. All right, what do the
6 and
signs need to
-2.
be?
Yeah.
Negative 6 and 2.
Yeah, that's what I meant.
Negative 6 and positive 2, because then those things added together give me a negative 4. So I've got x minus 6 and x plus 2.
Jeez.
12, c squared minus 9c minus 18. So I need factors of negative 18 that add up to negative 9.
-6, -3.
6. Yeah. No.
Yeah, no.
So negative 6 and negative 3 would give me a positive 18.
Oh, it's likely like a fraction or something.
Not.
Not factorable.
Oh.
There's no things that work. Now, I'll show you the factor tree would be like doing 3 and 6 and then doing 2 and 3 and then seeing if any combo of these numbers would work. Well, we tried obviously 6 and 3. You can try 9 and 2. Obviously, that's not going to work. 18 and 1, that doesn't work. So this one would not be factorable. But we would use these. This will be more necessary with the section for tomorrow. All right, moving into special types now. So these will either be perfect square trinomials or difference of squares. So we've got 16 b squared minus 81. So this is a difference of squares. Okay. What do you mean?
It's just 9.
Negative
so
9 and
it's
positive 9.
Yep. So it'll be b plus 9 and b minus 9.
That was easy.
Because when I FOIL this back, I would get b squared plus 9b minus 9b minus 81. So the plus 9b and the minus 9b cancel. So that's where that's coming from. So the signs are opposite on those ones. 18. T squared minus 16t plus 64.
T.
Might be negative 8,
Yeah.
So t minus 8 squared is how we write the ones that are a perfect square trinomial.
I just-
Now, it's a perfect square trinomial because, let me draw it over here since I wrote that close. We obviously have t squared there. 64 is 8 squared. So the first term and the last term are squared. The middle term is either minus or plus, either one. It just depends. But 2 times the first term times the last term is what gives us that one. And the last term obviously has to be positive because it is squared. So that's how I know that it was a perfect square trinomial. Because sometimes things look like a perfect square trinomial and they aren't actually. So always make sure you check before you just do that. 20.
21.
C squared plus 28c plus 196. Now,
Isn't that 13 squared?
no,
No, it's-
one higher. So I know for a fact that these are special types because it's in a section that's called special types or special patterns. So I know that this is either going to be a difference of squares or a perfect square trinomial. On the quiz or the test, I'm not going to tell you that. You're just going to have to recognize it.
C plus 14 squared.
Yep.
It's 14, yeah.
So this is 14 squared. This is 2 times 14 times c. So I know that that is a perfect square trinomial. So that means c plus 14 squared. And the sign that goes in here is always the sign of the middle term. 22. S squared minus 26s plus 169.
The 26.
Yes.
But this would be 13. It'd be it'd be negative.
Yep. S minus 13 squared. All right, so the next one say to solve the equation. So all of these have just been an expression and we're just factoring it. But as soon as they add an equals 0 on there, obviously it becomes a problem that we need to solve. And so we'll have to factor first and then we use that and we use the zero product property to solve them. So 24 x squared minus 8x plus 12 equals 0. So the initial part is the same as what we were just doing. Okay, these will not tell you if they're a special pattern or not. You'll just have to recognize if they are. The only way they can be a special pattern is if the last term is something squared. So anyways.
Negative 6, negative 2.
Yep, so factors of 12 that give me negative 8 are negative 6 and negative 2. So I have x minus 6 and x minus 2. And you probably know this, but the order that I write them in does not matter. So once I get to this point where I have it factored equal to 0, we take each piece and set it equal to 0. So we have x minus 6 equals 0 and x minus 2 equals 0. And then I just have to solve Obviously, these ones are relatively easy. They will get harder in the next section. But I just need to add 6 over, and I get x is equal to 6. Over here, move the 2 over. X is equal to 2.
And the right or.
I mean, I sometimes do, sometimes don't. Obviously, it can't be both at the same time, but if you want to write or, you can. I go back and forth. I don't take off if you don't write the or. Plus, it's like an inequality problem where you kind of have to write it, but.
I know, that's a great song.
28.
The first time.
B squared minus 6b plus 9 equals 0.
-3, -3.
So this is a special type, right?
Yes.
Because this is 3 squared.
B minus.
This is 2 times 3 times b. So that means that this is a perfect square trinomial. So this is b minus 3 squared equals 0. So all we do with that then is we just take the square root of both sides. And so I end up with b minus 3 equals 0. And then add the 3 over. So b is equal to 3.
I want to take a shoe.
All right, a different kind, 36. M squared equals 7m. So the first thing I need to do is I need to move everything to one side. I would probably recommend moving the 7m, but it's really not going to matter. So I would end up with m squared minus 7m equals 0. Now, this one is not factorable in the sense of how we've been finding the two factors and writing them times each other, but they both have something in common, and what would that be?
The variable.
They both have an m, so I can take an m out. So I have m times m minus 7 equals 0. And then now I can set each of those things equal to 0. So I'll have m equals 0. That's nice and easy. You don't have to do anything. And then m minus 7 equals 0. Add the 7 over, so m equals 7. So we have m equals 7 or m equals 0. All right, any questions on that? And I will tell you, if you struggled with factoring in Algebra 1, typically by the end of like us doing these sections in Algebra 2, it starts to like click and have like a light bulb moment. So if you're like, oh no, I was not good at factoring when I did it 2 years ago, most of the time it is easier and people start to pick it up. Because one, it's the second time you've seen it, and two, you just start recognizing patterns that you didn't necessarily see before. So, all right, problems. 3 through 35, every other odd. 3, skip 5, 7, skip 9, 11, etc., etc.